Good afternoon, everyone. Everything's running to time. Everything's running nice and snappy. This afternoon's talk here by Jackson. If you could save your questions until the end of the talk for this one. Over to you, Jackson. Thank you.
All right. Yep, that's on. Good. All right. So my name's Jackson. There's my Twitter account if you want to reference me on Twitter. So who am I? I'm a tutor for the, let's see if that's, all right, so who am I? I'm a tutor for the Introduction to Software Engineering course at the University of Queensland here in Brisbane. And so what that course does is it teaches Python to first and second year uni students at an introductory level. So we don't assume that the people have any Python background. And so I've done the course myself once when I was in undergrad, and I've been tutoring this course for about 3.5 years now, going on 4 years. So in that time, I've personally and individually helped almost 1,000 students learn how to program through this course. So I've seen a whole bunch of different things that the students will do, and I'm going to outline some of them in this talk. So what does a tutor do in this course? The tutors will generally do one-on-one help with the students, so show up and drop in prac sessions to help with your assignments. The tutors will mark the assignments and give feedback to the students on that, and sometimes the tutors will help the lecturer write the assignments and write the tutorials and things like that. So to give you a bit of an idea of what the demographics of the course are, we see, even though we don't require programming as a prerequisite for the course, about half of the students have programming experience before. So this data is coming from a voluntary survey that some students have completed going to the course this semester. Not every student's completed the survey, so the numbers are smaller than the class size, but it's roughly proportional. Of the 170 odd students who have done programming before, 72 of them have done it in Python, and several of them have done it in multiple languages. The demographics of the degree programs that we have about half of the class is engineering students, so usually software or electrical engineering, maybe a quarter or so are information technology students, and recently we've seen an increase in the number of science students, so not only computer science but other science disciplines taking this programming course. The class size over the last year or so has gone dramatically up, so traditionally the first semester of each year would be the more popular one to take the course in, but now we've got enrollments over 600 students for this semester. So the class numbers have been rising. We've been trying to figure out why, but it seems to be becoming a much more popular subject to do. So there's several problems. The learning environment, students will use IDLE to do their tutorial tasks and their assignment tasks. There's one other system that we've made that was written by the lecturer of the course, which is called MyPyTutor. And the idea is that students will be given several problems through the system, which I'll show you screenshots of in a second, and they'll be asked to do those for assessment, which is a very small part of the assessment in the course. So the idea of the way it looks is that you'll have, oops, I should have disabled that, you'll have some kind of problem statement here, and you'll be asked to write a piece of code that solves that problem or writes a function that does that. And if you write it correctly and you run it and it says you are correct, submit it to get the marks for that assessment piece. If you get it wrong, it'll tell you you're wrong, but it'll also do a bit of static analysis to try and tell you why you were wrong. So here in this case, I've accidentally tested if the entire string is a digit in this task, rather than testing if the character that I'm looping over is a digit. And the error message that it's telling me is that I should be using C for my isDigit test. So it's trying to give the student a more direct answer to why their problem is wrong. And hopefully that's helpful to the students. So in tutoring this course hundreds of times, what we see is that students will always do the same kind of problems or the same kind of issues over and over and over. And so I've kind of categorized these into about 3 areas. One very basic one is just in terms of the content of the language. How does the enumerate function work? Or how does a while loop actually physically work? What are the mechanics of it? How do string slices work? Actually having to tell the student, it starts at this character and it ends up to but not including this character. And for this, you just have to tell the students this is what the content is. And so what you need is you need some kind of language documentation. The easy, straightforward solution would be to point to someone else's documentation. Here's the Python language documentation in its complete glory. You could read that, or you could point to some other very good book or very good resource to do that. What we've decided to do in this course is to write our own notes for the students. And that's helpful for several reasons. One, because we get to decide exactly what content the students will read. Rather than reading the entirety of the Python language, they'll just read the stuff that we need them to learn. And secondly, we get them to read it in order of how they're learning it. So that's very useful for us. So an example of what's in these notes is we'll just tell them, the students, what the thing that we're trying to teach them is. So here's the enumerate function. Here's basically how it works in a short description. And here's a very, very simple example of what it's doing. So you can look at that and you can immediately see, now I know what the enumerate function is and how I'm supposed to use it. And then we give them some more complicated, maybe more practical examples of where it's used. And we'll generally also give them a broader definition rather than just an example, so you can actually see precisely what the definition of this construct is, whether it's a function that's commonly used or whether it's some language construct like an if statement or a while loop. So that's that. Second kind of more deeper problem is if the student kind of knows what the answer to the problem is in their head and then they have some kind of issue getting that problem into the computer, right? So there's something goes wrong somewhere between their brain and their keyboard, and it's hard to tell exactly where that goes wrong without wiring them up to a brain scanner. And then the third type of problem, I'll get to examples of this in a sec. Third type of problem, which is kind of similar, is problem-solving skills and the how do I start this problem. So kind of an anecdote for this is that a couple of years ago, I was telling a student or working a student through a problem which was very simple. Given a string, extract every third character out of the string without using a string slice. And so the student didn't know how to start this problem, so I asked them, okay, what if I was to write down a word on this whiteboard, and then I asked you to come to the whiteboard and underline every third character? How would you do it? Describe to me the process that you would do it. And the student's response was, I would go and underline every third character. And the student couldn't describe the answer to their problem any deeper than stating the problem itself. So that's an issue that students have. And obviously, it's necessary to be able to do that if you're going to write the code that will do that. So here's a few examples which come out of the course and some of the things that the students will do. So let's say, first task, given two integers, count the number of integers between them which are divisible by 3 or 5. So the problem right before this one is one which already involves something similar, summing up the integers. So hopefully students will get at least this far, where they've got some kind of while loop that increments this value that they're looping over up to their end value. And maybe they'll realize there's some kind of if statement and other stuff has to go around it. It takes a big step of logic for students to actually realize that you need some kind of tally. If you're going to return how many of these values match this number, you're going to need some variable incrementing inside this if statement to actually record that tally. So many students actually struggle getting this far. And then the last bit, obviously, is just what's the if statement condition. So if the student remembers from either the examples that they've done before or from reading the course notes that to check the visibility, you need to use the modulo operator and check if that's equal to 0. So obviously, n is divisible by 3 or 5 if n mod 3 or n mod 5 equals 0. So we write that if n mod 3 or n mod 5 equals 0. And obviously, the problem there is that you're not actually checking if n mod 3 equals 0. You're checking n mod 3. And so this is exactly the opposite of what the students want. And what they'll do, what the student will get at the end is an answer which is wrong. So your answer was this, it should have been this. And it will be very hard for the student to recognize where the problem is. So the tutor has to come in and tell them, actually you can't do this kind of English shorthand in code. You have to write out explicitly what it is. So that's that. Next example along similar lines is, say we're given two strings x and y. I want to return every character which is in the first string which doesn't appear in the second string. So the letters O and L don't appear in this one, so they shouldn't appear in the answer. Okay, so here's a correct solution which works, and hopefully hopefully many students will get to that solution, but they'll probably make several mistakes in between. One is that if you don't realize the roles of x and y in your solution, because your inputs are two strings and those two strings seem very similar in the problem statement and in your head in your solution, because you have to compare characters of the string in each other. So you'll accidentally do this and you'll get the wrong answer. Other things students will do is they'll not realize that there's a not in operator, and so they'll just check if a character is not equal to the entirety of the other string. So I mean, there's an exactness that the student's not doing, in that they're not realizing that not equals does not mean the same thing as is not contained inside. Another one that they'll do is they'll not actually tally up the characters which match, and they'll just return the first character which is there. So and what's really going on in the student's head is hard to tell here, but my guess would be that the students aren't really realizing that while the for loop for C in X, while the value of C would normally take on every value in X, they're not realizing that it's not taking on all the values at once. It's taking them on one at a time. So the student's not getting to the iterative process of the program that's executing, rather than just kind of reading the description of the program. Another one, indentation. So students will either indent too far or indent not far enough, or just forget to change their indentation when they're going from one line to the next. So they'll invariably return things inside of a loop, or not increment something outside of an if statement, so you'll get an infinite loop happening because you're not changing or you're not incrementing your values. So to fix that, maybe Python needs braces. Maybe I've just blasphemed too much. This last one is quite curious. Students will mistake the roles of print and return. And it's kind of hard to tell why this happens, but I think the reason is that what we do is we teach functions very, very early on in this course, because functions are quite critical to software engineering and designing good functions. So and then when students are running their code, they'll run their code just in the idle terminal and the idle shell, and they won't see the difference between print and return until we tell them that there's actually a difference. Like in this example, if you do it correctly with a return, you'll get this out, and if you do it with a print, you'll get this out. And to a beginner student, that doesn't seem like a problem, right? And it gets worse if your output is not a string, but something like an int or a list, where the rep is the same as the str, and your output in the idle shell will look exactly the same if you use a print or return. So students don't actually get that there's a difference here, and that's quite curious. Another kind of thing that can happen is that if the students do something wrong and the output that they get is just different to what the output that they expected is, it's quite hard to backtrack that and get to figure out where's the actual problem here. Like where's the source of the problem that's leading to this incorrect solution. So here's a problem. Take a dictionary and write a function which will filter out the keys in the dictionary which are bigger than this value. So A and E have values which are bigger than 15, and T and N don't. Right? So here's one way to do it, which is very common for students to do, and it's correct. So they'll add a list, loop over the keys, access the dictionary at the key, check if it's bigger than the value, and append it. Big problem that students make and they ask help for is when they actually forget to access the dictionary at that key, and they'll just compare the key against the number. So in a nice world, comparing a string against an integer would give you a type error, but of course it gives you true. Right? Obviously A is bigger than 15, and obviously empty string is bigger than 10 to the 100. Right? I don't know why that is, but maybe someone does. Yeah? Okay, in Python 3 it fixes that, so maybe we should switch to Python 3. All right. So obviously what happens in this example is that your filter doesn't actually filter anything, and you get the wrong answer, and you can't see why this wrong answer will tell you where in your code is wrong. Right? Obviously that's a critical thing in learning to debug, but for a beginner student, learning to debug and learning to write code at the same time is kind of tricky. Exception messages are also quite tricky. Value error, invalid literal for int with base 10. I'd argue that students wouldn't know what half of those words mean. Right? Type error coercing to Unicode, need string or buffer, list found. Maybe it should just say, you tried to open a list and you shouldn't. Right. So ways that this can crop up is in part of a problem, and it's taken from a problem that I'll show later. Determine if a string's length is divisible by 3. Students have sometimes accidentally left the len call off, so they'll do this instead. And so a helpful error message would be something like, you can't take a string mod 3, but obviously you get not all arguments converted during string formatting. Right? So that's one of the things I like about the MyPyTutor system that I showed you earlier, in that what it does is it's doing static analysis on the code so that it can actually tell the student what's wrong. And obviously that depends very heavily on what the task statement is. So every task that's written into the system has a whole bunch of static analysis code behind it. So it's a bit of effort to actually get set up, but students find it very helpful. Right? So what can we do? Can we avoid all of these problems entirely? And the answer is no. Right? So one of the things about programming is you have to be precise and exact, and you just have to learn that the hard way. But we can try and make this a bit easy for the students. Obviously, if you give the students a gentler learning curve, then that's kind of nice and easy. Obviously, there's constraints in any kind of teaching environment because you have limited time frames. So in a university course, you have 13 weeks to teach all of the content that you're required to teach, and there's assignments and other deadlines in the middle. So you can't just kind of stretch things out indefinitely, but you can kind of shuffle them around in a nice order. Keep the task motivated. Even though students have signed up for a university course and paid all the course fees, they still won't come to class, and they still won't do anything except the assessment. So you either have to give your tasks grades or convince the students somehow that the tasks are actually relevant to the assessment, even though they're not getting graded. And then this last one's the big one. If you give students problems they'll make mistakes on, then they'll learn those mistakes and they'll learn from those mistakes. Right? You're not going to actually learn any of the things that I've talked about earlier, those examples, unless you've made that mistake yourself and you've tried to figure it out and you've maybe had someone tell you, and then you'll know. So what I did earlier this year is I redesigned some of the tutorial tasks that go in other parts of the course to kind of fit along these lines. So here's one task that I wrote earlier in the year, and we used it last semester. Write a function is DNA, which returns true if the input's a valid DNA sequence, which means it has these letters, and its length is a multiple of 3, and false otherwise. So I wrote this thinking there's at least 2 ways that students will mess this up, and they did. And so obviously one thing the students will do, based on the earlier example I gave, is that they'll do this. And then obviously they'll get some value true when they should have gotten the value false. Sorry, they'll get the value false when they should have gotten the value true, and then they'll just give up because they don't know why their wrong answer, or where their answer went wrong and went false instead of true. Other things the students will do is, obviously if you find an invalid character, your answer is false. Otherwise, your answer is true. But then the leap of logic is to realize that your answer is not true when you find one valid character. Your answer is true when you've looped over the entire string and none of them are invalid. So students will make this mistake and their function will accidentally return true instead of false. And with a question with Boolean values as output, it's quite hard to tell because the only piece of information you really know is that your answer is wrong because it's not true, it's false. So students can't really work with that. Limited information in their output. We actually found, to my surprise at least, that some students took up to half an hour to complete this task, which I was quite astounded at. Another kind of task I've put in, this is kind of the only one of its kind, is a debugging task to actually help students take code that's wrong and fix it. So I've injected a whole bunch of errors in this code which deals with some prime numbers. You might like to try and figure out where the bugs are by inspection. There's at least 6 or so. So there's infinite loops, there's exceptions that get raised, there's values that will return wrong. And once students fix one bug, it'll uncover another bug. So I think that's kind of a useful exercise. So kind of all up, my summary here would be, 1, in terms of learning the content, give students nice resources, relevant resources that are useful for beginners and useful for exactly what you want them to teach. Obviously, you can't design tasks where the students will get stuck unless you know where they'll get stuck. So it kind of comes with the experience of teaching and improving your resources iteratively so that you actually solve these problems. And then kind of my third one, which I've sprinkled throughout, is give the students helpful errors. I mean, obviously, at some point, the student's going to need to learn proper debugging in a proper environment where the error messages they get are bad. But maybe very early on in their programming career, be nicer to the students so that you can at least give them that helping hand and then kind of take that away from them slowly when they find their own footing. So that's my thoughts, and I'll open it to questions.
Have we got anybody with questions? If you could just raise your hand and I'll pass you the mic. And right up the back here first.
That was really good. Question, do you integrate this system that you guys have thrown together with the learning management system?
No, we don't. So it's a fairly standalone system.
Just here.
Thanks, Jackson. So I guess one of the questions is, do Python error messages need to be as unfriendly all of the time at the interpreter level? Or is it that actually you need to give beginners less information than you would typically give an experienced programmer, on the proviso that mostly the kind of errors they're going to make are really simple? So, for example, with your string substitution example, you probably want to give a hint there, even if you don't, even if you want to leave the original error message there. Yeah. Whereas your open empty list thing, you could probably tell every programmer, don't pass the list into open.
Yeah. Yeah, so I guess kind of a mix of both. Because the other thing I haven't shown in the slides is obviously the big traceback messages, and actually identifying where in the code the thing's gone wrong. So yeah, I guess, well, in terms of the beginner level, you'd want kind of to avoid those kinds of things. And things like open list, people have done that, and that's why I've included that example, because not that they're intending to pass a list into open, but they open something and their function returns a list, and then they try to call their function again on that resulting value, things like that. So yeah, I guess that's that. But then on the other hand, obviously you'd want these error messages really to be useful only to the students, because then you'd want the error messages that exist for regular Python developers to actually get the full details.
Have you been tempted to use a language with a more strict type system for teaching?
I can't say that we have been tempted to use it, because Python works pretty well for our purposes, despite everything I've said. Yeah. That said, types are one of the things that we kind of struggle to teach students, because when students don't know what types they're passing around, which is very easy in an untyped language, they'll get all kinds of problems. One of the ways we try and get around that is that in the assignments we require the students to write a docstring and have included in that docstring the types that are going in and going out, so they're at least aware of that.
Have you thought about trying to categorize the types of errors that students are making, the types of mistakes they're making, with a view to actually forming some kind of catalogue of the top types of mistakes, and maybe feeding that information back to the lecturers, saying, hey, this is the most common misunderstanding students make, and it's manifested in these 3 or 4 different examples that we are encountering in our assignments.
Yeah. Formally, not really. Most of the feedback we give to the lecturer is kind of anecdotal, like, oh, this problem, lots of students have had this, that kind of thing. But and the lecturer will take those and kind of feed those back into his lectures, but nothing really formal.
So sort of 2 questions in one, I suppose. The first one is, do you know what static analysis techniques they're using to get that "you're doing this wrong" message? And do you is it logged what students are doing wrong, so that you could refer back to that if you wanted to?
Yeah. I don't know the answer to that because I haven't seen the entire source code for the system. So I'd have to ask the lecturer who wrote it. I don't know what kind of logging is happening. I know at the very least we log the number of attempts the students make at the problem, so we can at least see what problems are easier or harder than others. I don't know if we actually log their solutions though.
Yeah, I was just wondering, what methods do you use to teach students to debug? Like, do you just get them to read through their code and think about it, or do you like get them to write print statements through their code or something more formal like the Python debugger? Whatever.
Yeah. So formally, we don't give any upfront presentations or lectures or things to the students about debugging. In terms of when the students make their own mistakes, we'll try and walk through them and give them hints in the one-on-one sessions to help that. Yeah.
I'm just curious if you find many students use the submission system as a debugger.
Yeah, they do. Especially because part of the system is that it's kind of hard to, or it's very difficult to run the code locally without actually running it as a submission kind of thing. And that's kind of fine to work with because the submission, the marks that you get aren't affected by how many submissions you make. So there's that, and it's probably a bit of a caveat in the design of the system that you can't run it yourself and test it yourself easily without copying the code into idle normally. Yeah.
So, disclaimer, I used to tutor with Jackson in this course. This course has a lot of resources available to students. Like, there's multiple tutors who'll give you quite a lot of help. There's documentation and stuff. There's my PyTutor, and even the assignments have some level of instructions. Do you ever feel like you're giving people too much help, and if, like, in the next courses they're going to, like, struggle, like having to, for example, actually read real error messages instead of my PyTutor, for example?
Yeah. Not something I've thought about explicitly. I couldn't say, but yeah. 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 All right. Yeah. And to be honest, we have gotten feedback from the courses that follow on from this. Like, we got feedback last semester that students coming into second year courses aren't really good with debugging and that kind of thing. So it's possible that we're giving too much help, but then again, it helps the students learn more. So yeah.
I just wanted to add on to that because I'm actually wrestling with this right now because I'm going to be teaching some students programming later this week. And it's a bit of a dilemma to me, and I'm not sure what the right answer is, whether I should be just forcing them into the real environment, like use the shell, write a script, execute the script on the command line. All your code will be executed as linear code. There's no magic involved. There's no special hand-holding involved. And if you can write a script, you can write a script. And at least the framework around the code is kind of simple. But on the other hand, it's not a great learning environment. Like the feedback loop when you make a mistake is slow and clunky.
Yeah.
So do I put them in a nicer learning environment, like something like, I don't have anything as nice as that, but like IPython Notebook or something? Or do I just put them in the real world and say, okay, you've got to get past that and learn to program? And I'm not sure what the right answer is. So if people have experience with that.
Sounds like they do.
So I'll just put in a comment around how we upskill staff, as in the graduates who come in to work for us. Okay, so we often make our expertise, we don't find it. Okay, so like someone wants to come along, we say, oh, we need you to write Drupal code or Moodle code or whatever. Now, there's a balance, and I'm quite open with the team when I say this. You can ask too many questions and not try and figure things out yourself, or you can spend too much time trying to figure things out yourself without asking any questions. And it's a balance, and you need a feedback cycle in that process as well. But this isn't so much an academic sort of environment. This is more, they've got a lot of expertise around them, like one or two, junior developers with a lot of expertise around them. But some of these people don't necessarily engage or talk to each other, even if they sit next to each other all day and everyone's in the zone. But it is a real balance between making sure you're not... Like, it is good that they sit there and waste 3 days trying to figure something out that maybe only should have spent half an hour, because they actually think, oh no, that was really easy, now I know it, right? So there's an outcome from that, but you want to make sure you're giving them the ability to ask the questions so that they can benefit from the knowledge around them. And I suppose our approach is pretty much just to keep paying attention and just to sort of mandate interaction, and that might only be a half-hour sort of catch-up, just saying, how are you going, what are you doing, what are your problems, and don't sort of leave people to fester, but also let them know if they are asking too many questions and they need to figure some stuff out themselves.
Time for one more question only, I'm afraid. That chap over there in the corner.
Thanks. I was just wondering if it might get you to elaborate a little bit on one of the anecdotes you gave was a student not really recognising how to get the granularity on the question of getting every third letter. Just wondering what approaches you'd use to try to get the student to break down the problem.
Yeah, I mean, what I usually do is whenever I see that they really can't get anywhere, I just take an incremental step towards the solution. So I think, well, okay, what we need to do is look at we have this construct called a for loop where we get to look at every character in turn, and we have maybe some other things called enumerate, which let us look at what character we're up to, and so then ask the student, how can we use that? And then if they're still stuck, just give them an extra little hint and go that way.
Well, I'd like you all to put your hands together for Jackson. Thank you very much.